Hi, this is a maths admissions test workshop that I've run a few times when people have visited the University of Oxford for a maths event. I'm recording it so that if you can't make it to one of those events, you can see what I say. I'm James, I'm the admissions coordinator for maths at Oxford. It's part of my job to make sure that the maths admissions test runs smoothly, that we set it and mark it, and I look after the rest of the admissions process for maths too. I haven't done much video stuff before, so I'm really sorry if this is quite jerky or wobbly. I'm filming this on a laptop at home, so let's see how it goes. I'm going to use questions from 2015, 2016, 2017 and 2018. If you want to download the questions that I'm using in this workshop, there's a link in the description below. And if you want the full past papers and solutions, things like that, there's a single MAT website which is in the box below me. I've also put our departmental social media accounts in there. We're quite new to social media. If there's one we're missing, then let us know in the comments whether we should start a TikTok or a Twitch stream or something like that. Also, the email address down there goes to me and my team. If you want to ask us anything about maths admissions at Oxford or studying maths at university or Oxford or anything like that, then just drop us an email or leave a comment below. Okay, so let's get going with some maths admissions test things. First off, I'd like to talk about what the test is. I mean, it's an admissions test for maths. It's also used by computer science, though, and some other joint honours courses at the University of Oxford. It's also used by a couple of other universities. Check them to see what their policy is on the maths admissions test. It's a little bit longer than some of your other tests. It's 2.5 hours. And it's got this mix of multiple choice questions and longer questions where you need to show your working and explain why something's true, maybe do a little bit of a proof. It's not a calculated test. We try and write questions that calculators wouldn't help you much with anyway. And there's a single page syllabus. That's a list of the maths that we expect you to know by the time you do the test. That's on the MAT website, which is www.maths.ox.ac.uk/r/MAT. And that's that page that's got everything else you could possibly want to know about the maths admissions test. So the syllabus is based on mostly based on the first half of single A-level maths. There's no further maths on it. And there's a couple of topics that we think you might learn at the start of year 13 if you're learning maths over the course of 2 years. Those are marked with a star on the syllabus. Maybe check with your teacher to make sure that you will have seen them by the date of the test. This year, at the time of recording, test is 4th of November 2020. So this is maths that we expect you to know by then. Okay, a quick bit about why we do the test. We have some fantastic applicants. We have loads of great mathematicians applying to do our course. And unfortunately, we don't have the resources to interview absolutely everyone. We use the test as one way to help us decide who to shortlist. There's no hard cut-off mark on the MAT. The more you score on the MAT, the better. There's no hard cut-off though. We look at everything else on your UCAS application. The kind of only other academic thing that we have to go on is your GCSEs, and they were quite a while ago. We know that you might have got better at academic study since your GCSEs, and also not all of them are in maths. Maths GCSE is the one that's interesting to us. Other GCSEs, they're not in maths, right? And of course, looking at other applicants around the world, some of them didn't do any GCSEs at all, so it's not a fair comparison at all. So that's why we've got this one maths test that we ask everyone around the world to do on the same day. And it's a sort of fair test between everyone, closer to the point of application. So you sit the test. Before we've decided who to shortlist at all, we use that to help us make that decision. And then out of the people we've shortlisted for interview, those are the people, some of them we go on to make offers to later in the process. So this is an important step. It's another way for you to show us how great you are at maths problems. Okay, how to prepare for it. I mean, it's a maths test, so you'll need to think about some maths. You might like to start thinking about maths you've learned at A-level. Read that syllabus, that one page of maths that you might want to know. Sometimes people ask me, how do I know whether I know all the maths on the syllabus where it says quadratic equations? How do I know if I know enough about quadratic equations? So I've made a kind of warm-up problems exercise. This is a page of questions that are easier than math problems, and it's a way for you to check whether you know the maths on the syllabus. So it's kind of warm up problems. That's on the MAT website. Link is still in the box below me. You might like to do some past questions. That's the point of today's workshop. But you might like to do some other questions as well. There are loads of great maths resources out there. Things like Enrich for maths, puzzles, activities, games, and other tests like STEP, AEA, and TOMOA. Those are other maths tests. Actually practicing questions like this in general is a good way to get better at problem solving, which is going to help you not just with university admissions tests, but also for studying maths on a university course, and I like to hope also help you in real life as well afterwards, that having these kind of problem solving skills will set you up well for later life. You might like to try past paper under time conditions. That's a real thing for this test. You might be experienced at doing A-level papers in a fraction of the time that you're allocated. Here, because this test is a bit harder, that 2.5 hour limit might actually become relevant to you. You might find that you want to practice getting things done under time. Again, I'm not using any questions from 2019 today, so if you want to save that one for a timed practice, then the 2019 paper is also on our website below if you want to download that one for time practice. Okay, general tips. The multiple choice questions and the long questions are worth different numbers of marks. Let's see if I can write on this. There we go. So the multiple choice questions, you'll do 10 of them, and they're each worth 4 marks. You get 4 marks for getting multiple choice question right, and no marks for getting it wrong, and no marks for writing nothing. There are also long questions. You'll do 4 of those, and they're worth 15 marks each. Putting it together, this test is out of 100. There's a kind of back of the envelope calculation you can do now to say, oh, the test is 2.5 hours, that's 150 minutes, and it's worth 100 marks, so I should be trying to get a mark every minute and a half, and that gives you 4 marks for a multiple choice question, means I think 6 minutes on average for a short question and 22.5 minutes for a long question. That's a modelling approximation, of course, that 6 and 22.5 might vary from person to person. You might find that you're really quick at multiple choice questions, or you might find that you want to spend more time thinking about longer questions. In fact, we don't make the multiple choice questions kind of uniformly difficult. We like to make the first couple a little bit more approachable so that you can get a smoother start to this maths test. We think people probably do the first couple of questions first, and we want you to have a slightly more comfortable start. So maybe those ones take less than 6 minutes. This is our first approximation, 6 and 22.5. There's no penalty for wrong answers. If you put a wrong answer on multiple choice questions, there's no negative marking. If you write something that's not true on the long questions, we don't hold it against you, we just don't give you the marks. For those long questions, we encourage you to show your working out. Show us how you've got to the answer, especially on questions that ask you to show that something or to prove something. Show us what maths you're using to get from the start to the end, which might be a little bit unfamiliar. It might involve writing some words or explaining why you're doing particular steps or why they're allowed. Or it might just involve writing if-then down the side to say, if this is true, then this is true. There's quite a big difference between writing an equation where you mean, I'd like to show that this is true, this is my target, versus writing an equation where you're saying this is something that I'm claiming is true, and starting from there. And if you don't write any words, it's quite hard just from the equation for the markers to tell whether you're claiming something is true or whether you're trying to prove that. So adding a few little words in, maybe if this doesn't come naturally to you, you could go back and add words in down the left-hand side to add in extra context about what you're doing to help explain it to the markers. I haven't mentioned, but the markers are graduate mathematicians. They're really good at maths. They are fantastic at picking up if you've got some unusual method that they haven't seen before. They will work out how many marks to give you based on your new method. There's normally more than one approach to do long questions. Any approach is valid. So any way to get progress gets marks. Final 2 comments here. The questions are hard. They have to be, because the people taking this test, like you, are really good at maths, but the questions are not impossible. They sometimes look impossible. It's a totally normal reaction to look at one of these questions and think, I've no idea how to do that. That's sort of the point. We want to see you get over that barrier, to make a plan about how you're going to get unstuck on this question, and then execute your plan smoothly. So it's kind of pattern of don't know what to do, have a plan, execute. Is something that I'd like to try and show you over a selection of several past paper questions. Okay. That was all very vague and abstract. Let's look at some specific questions. Okay, here's a short question. It's B, so it's one of the earlier ones. And it's a question about an irregular hexagon. It's got equal length sides, and it's inside a square of side length 1. I'd like to know what the length of the hexagon sides are. And I'm not going to give you enough time to do this question during this video. I'm not just going to sit here while you do it. I'd like you to think about how you'd get started with this question. What's the sort of first things that you'd write down, or first approach that you might use? I'm going to give you about 10 seconds to think about how you might get going with this question while I drink some tea. 10 seconds, off you go. Okay, that wasn't even 10 seconds, but I'm going to start talking again. You can carry on thinking about this question while I talk if you like. So my first reaction was, I don't know anything about hexagons. there's no hexagon facts on the syllabus. I mean, if I really think about it, I know some facts about regular hexagons, I suppose, but this is an irregular hexagon. All I'm told is that its sides have equal length. I guess it's irregular because the angles are different. It's inside a square of side length 1. That's not on the diagram. And the equal side length thing is not on the diagram anyway, either. So my first reaction was, I want to label this diagram. In the real test, I'd have a physical copy of this, of course, and I'd start drawing on it. I'd put a 1 over here. The side length of this square is 1, and the side length of the hexagon is, I'm going to call it x. Giving things names makes it easier to talk about them. Side length of the hexagon is the thing we want to find. I'm going to call it x. And then I can make progress, because I can say this side over here, this side of a small triangle up there, must be 1 minus x, and also I think this side is the same, 1 minus x as well, and this is a right-angled triangle. Aha! Because I don't know facts about hexagons, but I do know facts about right-angled triangles. My plan now is that I'm going to write down Pythagoras' theorem. Pythagoras' name is a bit too long for this slide, sorry. But I'm going to write down Pythagoras' theorem for this little right-angled triangle at the top corner. And now I can relax, because writing down Pythagoras is something I can do. It's going to be some sort of equation involving x, because all of the sides involve x. And that'll give me some quadratic equation to solve, and I'm quite happy doing all of those things. And that's the pattern that is quite normal for math questions. Don't know what to do, have a plan, have an idea, and then relax when you try and execute that plan. Okay, I'm not going to tell you the answer to this question. I'm not even going to finish doing it. If you're playing along at home, then you might like to look up the solution on the MAT website in the description box below me. Okay, let's move on to a different question instead. Really not spending much time on any of these. Okay, here's a question. It's multiple choice. We'd like to know the largest one of these numbers. And I should say that this question involves logarithms. If you haven't seen logarithms yet, then, I mean, you can look forward to that. You're going to learn about logarithms at some point soon. They're fantastic. I'm going to slightly spoil this question. If you haven't learnt about logarithms, it's okay to just ignore option D and just think about the other 4 options for this question. If you have seen logarithms, please pretend that you didn't hear that, and please consider the logarithms as maybe being the largest one. I'm waffling because I want you to think about how you'd start going with this question. Again, we're going to solve it during this video, but I'd like you to start thinking about how you'd start to make progress. Okay, I'm going to give you about 5 seconds this time. Okay, so my first plan when I saw this question was I should try and convert these questions from fractions, try and convert these numbers from fractions to decimals. Here's my attempt at doing that. So 5 over 4 is 1.25. That's pretty good. Root 7 over 2, I don't know, but I could probably try and work out root 7 a little bit. This one I really don't know, and the others I also don't know. So converting them to decimal is easy for one of them, 5 over 4, but then really hard for the others. And I could probably put in some work to try and work out what these things are in decimal. But this plan feels really complicated, like this is going to take me a long time. And there's an important skill here to say, I've come up with a plan, convert them all to decimal, which I could probably technically do. But this plan doesn't seem like it's going to make much progress for me. It's going to take me a long time. And sometimes when you come up with a plan, you need to adapt it or choose a completely different plan if it's not going anywhere. So here, my first plan is not fantastic because I'm about to try and work out some square roots of some numbers. I'd like to swap to a different plan. Probably you're shouting a different plan at the screen right now, and that's something like we should compare pairs of numbers. So we can look at pairs of these numbers and say which one's bigger. For example, we could look at both of these, root 702 and 5 over 4, and we could try squaring each of them. Squaring each of them is nice because the one with the biggest square will be the bigger number because they're both positive. And squaring gets rid of that square root on the 7. So we'd be comparing 7 over 4 with 25 over 16. And comparing those fractions with that square root might be something we can make more progress with. So comparing pairs like that might let us fight these off gladiator style until we're left with one surviving biggest number. Of course, we're going to have some ideas about that logarithm, and we're going to have to do some actually quite clever stuff to work with the other ones with square roots in to try and work out what happens when we compare those. So once again, I'm not going to tell you the answer to this question. I'm not going to tell you how to do the rest of the question. This one's a little bit harder. You need to do quite a bit more work to compare some of these numbers. You need at least one idea about logarithms if you're doing the version of this question with logarithms in. If not, then you will see logarithms at some point very soon, I'm sure. Okay, solutions again on the MAT website. I'll let you think about that one yourself though. Okay, one more short question. Here it is. This is from 2018. This question is about two parabolas. Their equations are x squared plus c and y squared equals x. And they meet tangentially at a single point. We'd like to know the value of c. So I'm going to give you a moment again to start writing down how you would get going with the algebra for this question. And I'm going to give you the clue that I think this is more of an algebra question than a geometry question. So scribble down some algebra. I'm going to give you 5 seconds. Once again, off you go. So here's the algebra that I wrote down the first time I tried to do this question. I wrote down x squared plus c. Because you see, I want this as my y value, and I want to plug that into the second equation. So I'm going to take that and square it and set it equal to x. So now I've got an equation, and I want to relax, but unfortunately it's got two variables in it. It's got x, which I don't know where this point of tangency is, and it's got c, which is the thing I'm trying to solve for. So even if I multiply this out and get some horrible fourth order equation, quartic equation, I've got two things to solve for, and it doesn't feel like I can normally do that off one equation. So just setting these things equal to each other hasn't been enough. I need another idea. And one idea that I think is really useful is to say, if they meet tangentially, they've got a common tangent, the tangent has the same gradient as the derivative at that point. So I should write this one as y equals square root of x, or x to the 1/2, and then I should set the gradient or the derivative of each of these curves equal to each other. So I should have 2x is equal to 1/2 x to the -1/2. And that gives me a second equation. So I'm saying that they have the same value and they have the same derivative at that same point of tangency. That gives me a second equation for x, and I think now I can relax because I've got two equations, two unknowns. They're pretty gnarly equations, but I reckon I can probably go and solve those. I've turned it from a geometry question into an algebra question. So third time in a row, I'm not going to tell you the answer to this question. I'm not going to tell you how to do that algebra. Hopefully you can make an inroad with that algebra, given some sort of plugging things into each other and solving quadratic equations. Should probably do it from memory. Right, okay. I'd like to finish by showing you a long question. We're going to do this one slightly differently. Firstly, here's all of the long question. Here's all of the text for the long question. There's normally a sort of single idea or some common thread going through the question. This one's going to be about a number alpha with a particular property. It's a bit of an unusual property. It satisfies some equation. And there's lots of reading to do, so I've put boxes around the parts where we actually have to do something for this question. So there's this first standalone part to show that alpha is between 0 and 1. And as I read that part of the question, I think, I know about cubics. They tend to go up. Sometimes they have turning points, but they tend to go up. So if I can prove that this goes through the right value, then I could say that there's probably a solution to this equation. Left-hand side equals 1. At some point in between. So I could maybe think about what's going on at 0 and 1 and talk about what's going on in between. So let's show that question. So we need to explain why that's true. And then there's sort of a separate second part, which asks us about alpha to the 4. We've got this equation with alpha cubed in, and now we want to find out alpha to the 4. My reaction when I read this was to think, well, maybe I should multiply through that first equation, multiply each side by alpha, and then I'll get an alpha to the 4. I'll have some other things that I've got to deal with, but I've made a start by getting this alpha to the 4. So I want to show that alpha to the 4 is equal to some particular quadratic in alpha. So there's going to be some rearranging to do, and I probably need another idea, to be honest. But I only know this fact about alpha at the top there, so that's the only thing I know about alpha. I should probably work with that. Third part of the question is going to develop this idea to say that some expressions in alpha have nice quadratic expressions that are equivalent from this fact about alpha. It's kind of the only thing we know about alpha, is that alpha cubed plus alpha squared is equal to 1. So when I look at the rest of these, I'm going to try and use the same idea. Before I was multiplying through by alpha, and now I want to express things like 1 over alpha as this quadratic in alpha. So I'm going to probably try dividing by alpha cubed or doing something to try and get a 1 over alpha in that expression somewhere. There's a few more parts of this question to do the same thing with infinite sums and with things like 1 plus alpha, 1 over 1 minus alpha, things like that is a lot of fun. And I'm going to let you have a go at that question because I think it's important to try this and try experimenting with different things. I really like this question because it lets you mess around with other expressions of alpha. We give you this thing alpha cubed plus alpha squared is 1 that probably you've never seen before, and we ask you to infer things from that. So that's how it works as a show that question. We want you to start here and infer things afterwards. Okay, and I think rather than listening to me do it, the best thing for you to do next is to try doing this question. So download link in the description below, or you can get the entire past paper that this is from off the MAT website. Link is hopefully still in the description box below me. I've recorded this. Hopefully I'm going to record more things as support for people on events, so that if you can't make it to an event in Oxford, there's something else for you to watch online. Have a nice day. Take care. Bye.